We are back now to do our little bit of square root review. Square roots are the most common roots that we ever work with, and yes, we need to be pretty good at them. So the first problem is simply an addition problem. The question is, can I add a square root of 45 with a square root of 20? And the answer is no. They have to have the exact same number in the roots to be able to add them. So hopefully you'll recall that you need to break down your roots, and then you see if they have like radicals, you can add them together. So we're looking for two numbers that make 45. One of them has to be a perfect square number. So we're thinking 4, 9, 16, 25, 36. And yes, 9 is a perfect square number that goes into 45. So if that's 9 times 5, I can take the 9 out of the root because the square root of 9 is 3, and I would have 3 times the square root of 5. We're going to do the same thing with 20. What are two numbers that make 20, but one of them has to be a perfect square number. You can't use 2 and 10. Neither of those is a perfect square. But 20 is really 4 times 5. So when I take the 4 out, square root of 4 is 2. The question is, what do I do with it once I get it out here? I multiply it times the number that's already out front. So 2 times 2 is going to give me an answer of 4 times the square root of 5. Now I ask myself, are any of my roots alike and that I could add it together? And yes, once you add, it's like adding variables. 3 square roots of 5 plus 4 square roots of 5 gives me a total of 7 square roots of 5. Okay, so addition and subtraction, the only thing you can do there is break down your roots and then try to add up the ones that are like terms. If they're not like terms, then you have to write them down as separate. Okay, the second one is fraction, and we all hopefully remember the term rationalizing the denominator. Rationalizing the denominator means we are getting rid of the square root in the denominator. And some of you may be screaming, multiply by square root of 50 on top and bottom. And yeah, that'll work, but that's going to give you hideous numbers and a lot of work to break it down. You are smarter first to ask yourself, can I break down square root of 50? Then see where I can go from there. Well, we know square root of 50 is really, once again, looking for perfect square numbers. It is 25 times 2. So the 30 is not in a root, it stays on top. Square root of 25 is actually 5, and you would be left with a square root of 2 on the inside. Now, once again, yes, I want to get rid of the square root of 2, but also notice the numbers that are not in the root, we have 30 over 5. Doesn't that reduce? So yes, I would take and cancel that, which would take me down to 6 over square root of 2. So if I'm down to that point, now I go, okay, how do I get rid of square root of 2 in the denominator? We don't want to have to do common denominators with square roots. So we discovered with square roots that all you have to do is multiply by the same roots in the denominator. Because once again, the magic of mathematics helps us out. On top, I'm going to end up with 6 times the square root of 2. On bottom, what do you get when you take the square root of 2 times the square root of 2? Well, technically, it's the square root of 4, but that's really just 2. Anytime you take a square root times itself, you just get the number inside. So that's just 2. Look at your final answer. Is that reduced? And your answer would be nope, not reduced. So you would cancel 2 into 6, which would leave you 3. And you will now have 3 times the square root of 2 as a final answer. Something you probably wouldn't have guessed was going to be your answer when you looked at the original problem. So sometimes working with square roots, that actually took quite a few steps, nothing all that difficult, but you have to be able to work with it to get it into a proper usable form. And that answer is considerably more usable than most of the stuff we saw along the way. All right, you may be looking at this last problem going, that's going to have a lot of pizzazz. Okay. Once you have 2 terms in the denominator, notice we've got 2 here, you can't just multiply by square root of 7. Don't write this down, because I'm going to erase it. If I times it by square root of 7 to try to rationalize it, I would have to take square root of 7 times both parts. Well, all that's going to do is get me 5 times the square root of 7. It's going to move the square root of 7 over to the other side, but we still have a square root in the denominator. So we certainly don't want that. So instead, we need something that will help us get rid of the square root of 7, But since we have two terms, that presents a problem. So we are going to instead, when we have two terms, we multiply by the conjugate again. Conjugates are our buddies. So the question is, what's the conjugate of 5 plus 3 squared root of 7? Well, conjugates are formed by taking the exact same numbers and simply changing the one sign that's in the middle. You're always going to do the conjugate of the denominator. We're trying to get rid of the square roots in the denominator, and conjugates will do that. So the top is also going to be multiplied by 5 minus 3 squared root of 7. Now, yes, you guessed it, it's foiling heaven. So, I personally always do the bottom first. You don't have to, but I do. Because I always know when the conjugates are there, the two on the bottom are conjugates, I only have to multiply the first and last of my foiling, because the outers and inners are going to cancel. So you do not need to do the outers and inners. Just do first. 5 times 5 is 25. Then do last. 3 squared root of 7 times a negative 3 squared root of 7. Okay. So 3 times 3 is 9. Square root of 7 times square root of 7 is 49. Well, that's really just, square root of 49 is really just 7. So all I have is 9 times 7, or 63. So this is really just 25 minus 63. What do I get when I subtract that? Well, hopefully your brains are in here. And I'm going to get negative 38. And hopefully the warning bells are going off. We can't leave a negative number in the denominator. We'll have to fix that at the end. But you must get rid of the negative in the denominator. That's an important thing we're going to have to take care of as the last step of this problem. Now, the bad news is, on top, there's no conjugates. Two totally different expressions. So you have to FOIL the entire thing. So we're going to do first, 4 times 5 is 20. Outers. 4 times negative 3 squared root of 7, that's going to be negative 12 times the square root of 7. Inners is going to be negative 10 times the square root of 7. And then last are always the ones to be aware of. Now, I would prefer you learn the shortcut to this. Negative 2 times negative 3 is positive 6. What is square root of 7 times square root of 7? That's really critical. You need to know, yes, square root of 7 times itself is square root of 49. But really, square root of 49 is just 7. If you take square root of 7 times square root of 7, you will get 7. So you just have 6 times 7, or a combined 42. Now add up your like terms. 20 plus 42 is 62. And negative 12 minus 10 square root of 7, that's negative 22 square root of 7. Finally, you have to ask yourself, am I done? And there's two things to check here. One, could I reduce everything? And two, I have to move that negative sign. I'm going to move the negative sign first. So, since the negative's on the bottom, you can move negatives from top to bottom. Negative 1 over 2 and 1 over negative 2 are still the same value. So you can move negatives from top to bottom wherever you like. I don't like it on the bottom, so hey dude, you're going to the top. So that's going to become a positive 38 in the bottom, negative 62, positive 22. Now, the other thing I hope you're noticing is that 62, 22, and 38, those are all even numbers, so that it's got to be reducible by at least 2, if not bigger. You can only reduce the numbers outside the roots. You can't reduce any number inside the root. But all three of those, 62, 22, and 38, they're all divisible by 2, so we need to reduce this entire problem by 2. So that's going to leave me negative 31. Divided by 2 out of 22, that's going to be positive 11 square root of 7. And then finally, reducing the 38 by 2 will give me a 19. Now look at it and go, is there anything else that reduced 31, 11, and 19? I don't think so. So there we have a final answer. Know that seems like a lot of work. It's really not that hard, just a little bit of time to get it all knocked out. But there are times when it certainly proves useful that we wouldn't want to have to deal with numbers that had 5 plus square root of something in it. It's harder to deal with. So being able to rationalize it and get it out of there is important. Hopefully that all makes sense. If you've got questions, you know where to find me. Good luck.